Hello everyone. In this video, I'm going to talk about the challenge of real-world reinforcement learning or use cases autonomous vehicle. My name is Yousef. Okay, here you see the outline. We talk about the following challenge: continuous state and action space, partial observability and non-stationarity, unspecified and multi-objective reward function, explainability, real-time inference, system delay, safety, final comment, and finally present reference. Okay, the first challenge that we are going to talk is about high dimensional continuous state and action space. Each challenge has two part technical description and example. Here you can see the technical description related to the continuous state and action space. In many real world applications, the state and action space can be high dimensional and continuous, making the learning process computationally expensive and complex. Okay. For example, in autonomous driving, we have continuous and high dimensional state and action space. The state in autonomous driving is get from lidar, sensor, camera, and radar. We have a high number of feature, and we have continuous feature. And the action space involves continuous control of steering, acceleration, and braking. But what is the solution? How can we manage the situation? We need to use policy-based deep reinforcement learning. Uh, these policy-based reinforcement learning, such as proximal policy optimization, uh, can be employed to handle high-dimensional space. The second challenge is partial observability and non-stationarity. Autonomous vehicles often operate under partial observability due to sensor noise or limited sensor range. Okay, autonomous vehicle don't have a full view or full observability. They have a partial observability due to sensor noise or limited sensor range. But what is non-stationarity? When we have multiple agents operating on the same environment, the environment is changing frequently and change are dynamic. That result in non-stationarity. Okay, example in autonomous vehicle. So imagine an autonomous vehicle that operate in urban environment. This autonomous vehicle doesn't have complete visibility due to the parked car or building blocking its sensor. Okay, it must make decision based on incomplete information because the autonomous vehicle has a partial observability. It should make decision based on incomplete information. Imagine under a UAV and some ground sensor. UAV cannot communicate with all of these ground sensor, and in each time slot can communicate with one ground sensor and receive data. We say that this UAV has partial observability. Okay, when we face with partial observability, we have to formulate a problem using partially observable Markov decision process or PAMDP, and we need to recurrent neural network or integrate recurrent neural network in our solution. Please, when you formulate a problem, for example, problem related to the robotic, problem related to UAV, consider the practical aspect of your work. For example, for a robot, you cannot formulate problem using Markov decision processes. A robot doesn't have a full observability, and you have to formulate your problem using PAMDP. Okay, this challenge is unspecified and multi-objective reward function. Defining reward function for autonomous vehicle is challenging as they need to balance multiple objectives. What are these objectives? Safety, efficiency, comfort, and compliance with traffic rules. Okay, an autonomous vehicle need to optimize for safety, efficiency, passenger comfort, adherence to traffic law. We have to optimize multiple variable and we have a multi-objective problem. In this case, we have to use multi-objective reinforcement learning to handle the problem. Okay, explainability. For autonomous vehicle, it is critical to understand and interpret the RL model decision. Okay, it is very critical to understand and interpret RL model decision because when we have such understanding and interpretation, we can have a safe system that align with human expectation. Uh, Also, you can see here that explainability is essential for gaining regulatory approval and user trust. When our system is explainable, when we can justify decision, uh, people trust in our system. When autonomous driving system is explainable, people better engage in using that and can better trust to it. Example, when an autonomous vehicle, for example, collide with another car, it is important to explain why it happened. Okay, what is the root and cause of this problem? Or, for example, we have a UAV acting in a search and rescue scenario, in energy scenario, and other scenario. We want to know the root and cause of the usage decisions that are being made with the UAV. This is critical for us. We need an explainable system. Explainability is critical in autonomous vehicle. How can we achieve this? We can use technique like saliency map or SHAP to analyze the system and highlight and understand which part in input are responsible for the output. Okay, this is very critical. This explainability is a very hot topic nowadays, and explainability in conjunction with autonomous vehicle easily can be a PhD thesis, and we work on it. Okay, real-time inference. Autonomous vehicle must make decision in real time to react promptly to dynamic environment. This require highly efficient algorithm capable of fast inference. Okay, an autonomous vehicle must quickly process sensory data to make a split-second decision, such as avoiding a suddenly appearing obstacle. Thanks to deep learning algorithms, nowadays autonomous vehicle can make a real-time decision in less than 1 millisecond. Okay, system delays. System delays occur due to the time lag between executing an action and observing its effect. For example, imagine an autonomous vehicle. We have network communication delay, we have action execution delay, and we have sensor processing delay. Okay. When we design a solution based on reinforcement learning, we have to consider all of these practical aspects into our problem, especially the system delay. Safety. Safety is paramount for autonomous vehicle, as incorrect action can lead to accident. Okay, safety constraints need to be integrated into the RL process to ensure that the vehicle operates within safe boundaries. It is a very hot topic nowadays. Um, how can we achieve safe autonomous vehicle? This is very important research topic, and this safety in conjunction with autonomous vehicle, we can develop some PhD thesis. Example: an autonomous vehicle must navigate complex environment while avoiding collision with pedestrian and other vehicles. The same is true for a UAV. Okay, UAV, imagine a parcel delivery scenario by a group of UAV. Okay, this UAV need to be careful to avoid collision with other UAV, to avoid collision with environmental obstacle, and they have to navigate this complex situation. Okay, oh, safety is very critical in such a situation, such as navigation of the multiple UAV together. But how can we achieve to safety when we have a safe when we want to formulate a problem that using safety, we have to formulate a problem using constrained Markov decision process and incorporate safety layer. But how can we incorporate a safety layer? This is a big question. As a research trend that nowadays I observe is used, we can combine reinforcement learning and optimal control theory together to make RL system safe. This is a very, very hot research topic. Final comments. IEEE reviewer prioritized papers that address real-world challenge and provide practical solutions. As the IEEE reviewer, I would say that um, this sentence is 100% correct. We are interested in problems that address real world challenge and provide practical solutions. When you want to write a proposal, when you want to design a solution, always you have to consider the practical aspect of your work. You need to be careful about all of the points that I mentioned in this video. All of them are critical. You should respond to each one of them separately, then develop your proposal and consider this practical aspect. Of course, we are interested in real world challenge and practical solution. Their rigorous evaluation process ensure that contribution to the field of autonomous vehicle are not only theoretically sound, but also practically relevant, safe, and innovation. Yes, we are not seeking for a mere theoretical solution. They should be practical and innovative. And ignoring practical consideration can lead to significant challenge during the review process. When reviewer provide their feedback to you and you are going to write your response letter, you will be faced with critical challenge. All of them are interested in the practical aspect and provide question on it. So be careful and please consider aspect discussed in this video. This is my reference, challenge of real world reference reinforcement learning that is available in archive. Thank you very much. If you learned something from this video, I appreciate to like and subscribe. Thank you.